So typically something like right, so public static void main string bracket args. Right, so when you run this, if you go into properties and you go under run debug settings and you put up the arguments and you say blah, then when you run your code, args bracket 0 will be, you know, whatever that first argument was. And if you had multiple arguments, they would appear in successive elements of this array, right? And args dot length equals number of arguments that you specify. So let's just look at that. So in your code, you know, you construct a scanner on some sort of file name. Let's make yet another project. So let's just make one class. Alright, so if I run this, it should tell me that args.length is 0, right, because there's no argument specified. So if I don't know which perspective this is. Alright, so I set my arguments to haha, this is fun. And I run it now, args.length is 4. Right? And if I want to actually pick up that argument, I can look at, for example, args bracket 0, and it's equal to haha. So the idea was that if I want to point your code to a particular database file, instead of going in and editing your code, right, I just come in here and I put in a command line argument, and then your code should be written so that it looks for a command line argument. If it finds it, it uses that as the file name.
Okay.
Otherwise, you got to find all the places where you touch the file, and some people, they use the file 3 or 4 different places. Right, once in the beginning, once at the end of the game, once at the top of the loop, and so on. So you set it up to just work with a file. And then if you wanted to, you could say if args.length is 0, there is no command line argument, then just use some default location. And that lets you test it kind of more easily like that. So I don't remember what exactly I saw in your code. I think you weren't just doing anything with args, if I remember correctly. I can go back and look at it. So PA4 looked good. A few issues with the command line arguments, right, which we just talked about. But by and large, everything worked fine, right? So the gameplay was fine. The update of the tree was fine. In most cases, writing it back out to the file was fine. I had some challenges with some people wanted uppercase YES instead of just Y, and some cases if you didn't say uppercase YES it took it as no. So I would say Y, but it would actually take that as no, and so it looked like it was doing weird things, and so it can be helpful to put a little one line of instruction in the front, or actually check to see if you got a response that you were expecting, and if not, then say please enter yes or no, right? Which some of them did. Or just use buttons, right? So that's the nice thing about GUIs.
Mine was really dumb in that it put everything to lower and then removed everything except the first character.
Okay.
And if the first character was yes, it was yes, and if you typed literally anything else, it was
okay.
no.
So infinity minus 1 is no.
It was a massive net, I think.
Yeah.
You could type onion and it would be no.
Right. Nice. So yeah, so that seemed to work well. And several people did GUIs, and those were nice to work with. Also worked well. I don't remember who did this, but one GUI, it just maximized itself, and I have a 50-inch monitor at home. So it was yes, no, awesome. Plus it had some cool artwork in the background, so it was so that was nice. All right. All right, let me pause this. All right, so any other questions on PA4, PA5 so far? So let's play with client server a little more. So we're on the Linux server. Nothing happened. So this client server model is really kind of central to most of what we do with computers today, right? All of the cloud stuff, all the networking stuff that we do is built on top of this client server model. So we talked about netstat, which shows you network information. -A says show me active connections. -n says show me the numbers instead of the names. And I'll just look for TCP connections. And there aren't too many of them. Fewer if I can't type. There we go. So there's some of the TCP stuff going on. And most of these things are in a listen state. There's 2 connections that are established. And so if we get rid of the -n, it by default translates these things. So these established connections are Linux engrcs.com:/SSH. Those are secure shell connections. Those are people who are probably puttied into the Linux server. And so there's 3 connections for that. There's an HTTP connection down here at the bottom, which is established. So somebody's on a web page for the server, which is probably my job at Virginia Tech. There's a MySQL connection. There's a server running in the background that's looking for database requests. Right, we might get to some database stuff in here this week or next. And up at the top there's something that says SMTP. So that's Simple Mail Transfer Protocol. That's the mail daemon, and that's port 25. And remember, if you look at ETC services, you'll see a list of port numbers and what they're associated with. So port 25 down there at the bottom says mail, right? So that's how mail gets sent around on this machine. And I don't have any mail. So sad. If we telnet to port 25 on this machine, we're talking to the ESMTP server. And 220 tells us it's giving us a piece of information. That's the piece of information it's getting. Well, we can introduce ourselves, so we can say hello, Nick's laptop. And it comes back and it tells me what its name is, localhost.localdomain. So we're introducing ourselves to each other. So I can say mail from, and I can send a mail message. So I'll say mail from, let me get from SpongeBob, and it says okay. And I'll go recipient to, and I'll send it to Nick. And it says okay. Anybody here want mail? What's your login name on Unix?
KSTENNFELD.
Okay, says okay. And then I can say data, and now I can type in what I want to actually send. And you end it with a single line containing just a period. So hit carriage return, hit a period, hit carriage return again. So I can say from SpongeBob at SpongeBob@patrickshouse.com, and it goes to Nick. And Kyle. Subject, this is silly. Putting a blank line. Alright, and then we'll just end it with a single period on a line. And it's queued up my mail message. And if I quit out of Telnet now, hey, I've got mail. And who's it from? It's from SpongeBob. So I can go into my mail program, and I can look at my first message, and it says from SpongeBob@patrickshouse.com. And it's going to myself and Kyle. And there's nothing magic happening here. It's just C code. And since I'm just making a Telnet connection to port 25 and sending in information to compose a mail message and deliver it, it has no way of knowing who I am, other than who I tell it I am. So it thinks this is coming from SpongeBob. Right? So if I want to send mail to somebody from somebody else, it's really easy. Now, if you just look at the message itself, it says from :SpongeBob@patrickshome.com, but if you look higher up in the headers, you can see it was actually SpongeBob at localhost. Right? And this happens with spam that you get also. If you just look at the headers that you see like in your mail program, it looks like, oh, this is coming from security.clark.edu. It must be legit, right? Then you go up in the top and you see some Yahoo address or something like that. But, basically pretty easy to spoof. And this is really nothing more than a file. So there's a directory var mail, and each user who has mail gets a folder in here, a file. All right, and if I look at Nick, it's text. So what happens when you make a connection to port 25? There's a program running, which is listening for connections. Connection request comes in, it accepts it, starts a process that looks for hello, looks for mail from, recipient to, data, and so on and so forth. And once everything has been sent, it goes ahead and it just tacks all that stuff onto the bottom of this file. And now it's a new mail message. And when I say mail, it opens up this file and it looks for the headers, and it shows me the headers, in the beginning like this, and lets me look at messages one at a time and so on and so forth. And it's just code. And it used to be that you could sit on another machine, you could telnet to port 25 on linuxengrcs.com and send mail to somebody. It's not that easy anymore because you could do that, right? You could shut down machines really easily. Just fill up their mailboxes by sending a bunch of messages. So if I come back onto my Linux machine, my laptop, and I try to telnet to port 25, it's not going to accept that connection. It'll sit there for about 2 minutes and eventually it'll time out. Right? So that's basically the role of firewalls. And so here's the Linux machine. And here's our firewall. And there's a router usually somewhere. And so linuxengrcs.com, that translates to 70.35.202.249. And so if I say telnet linuxengrcs.com 25, right, which is that address, I'm talking to this router. I'm not actually talking to that Linux machine. I'm talking to a piece of networking hardware. And I'm saying, hey, can you pass a message for me over to port 25 on that machine? And it may say yes, it may say no. Well, in this case, it's saying no. Right? So most ports are disabled on routers so that if you try to connect to a machine through a certain port number, you're not allowed. But sometimes you turn ports on so that you can get through. For example, if you want to access a web page on a machine, you have to go through port 80 or port 8080. So those have to get forwarded. The other thing that happens is with routers, you might have multiple machines being served by a single router. So this router might point to several machines, and they all share the same actual address on the actual internet. And so if I telnet to this at a particular port number, again, I'm talking to the router, not to any particular machine. And inside, this might be 192.168.2.2, this might be 2.3, this might be 2.4, and so on. But I can't from the outside world say talk to 192.168.2.2 because that's a bogus address. Right? That's not an actual address on the whole internet. Right? So I need to somehow talk to this address and say, hey, but I want to talk to this machine over here. So in your router, right, you do port forwarding. You say anytime you get a request for port 25, send that on to 192.168.2.4. And now this machine can handle those requests. So if you have a web server, right, you put on a port forward and you say packets going to port 80, send them over to that machine. And by default, most of the ports aren't passed through, which is why it acts like a firewall. Right? If you want to come in from the outside world and do something on a machine, you don't have a way to get to it. You don't have a way to get any connection to those machines. So it's like a firewall. On the other hand, port 80 is available. Port 80 is the web server. So I can, from my laptop, connect to linuxengrcs.com port 80. And I can say hello. And it sends back a bunch of stuff, which says bad request. Your browser sent a request the server could not understand. And all of this stuff that is sent back, this is HTML. Right? This is a bunch of human readable text, but it's got these tags, these things in angle brackets. That's a markup language. And it controls the formatting of this if you know how to interpret that markup language. So I can make a file called badrequest.html and paste all of that stuff into it. And put that on my desktop. So if I go to Home NIC Desktop, alright, so there's what my desktop looks like, and if I pull up, oh, where did I put it? Bad request.html, right? That's what that server actually sent me. So when it says title 400 bad request, right? That makes that big bold bad request in big font. And down here when it says, you know, paragraph, your browser sent a request the server could not understand, it put a break in there. And down here where it says HR, that's a horizontal rule that makes this big horizontal line. And then we have this italicized section down here at the bottom where it says address, and that puts it into a particular font and size and so on. It's just code again. So your browser is doing a couple of things. It's making requests to port 80 or 8080 on remote machines, and then it's taking the information that comes back and it's presenting it in particular formats based on what those tags are saying. So what's a good request? Well, you can say get and ask for a page. So if I say get/index.html, I get back a bunch of stuff. It says ECS course policies for additional course policies. So what are we looking at here? This is our linux.engrcs.com website. So somewhere up here by the top, this looks like the pages that point to the different syllabi, so engineering 250, 252, 253, 270, and so on. There's the ECS club and all of that. And that's what happens if you go through a web browser to linuxengrcs.com. That's what you see. And the syllabi are over here. So when you go to the shared area on Canvas, it's going to the Linux server and it's looking under ~nic shared 223, and there's different directories under there for different uploads that we've made. So list main.java, that's a lie. Get uppercase. So file not found. Well, okay, let's see where it is. Lists with an S. Main.java. Alright, one more try. So I'm running Telnet, but I'm fetching files from the Linux server. So let's do this in code. Alright, so let's make a socket. Let's make a scanner. Let's call this socket to server. Let's call this scanner read from server. And I'm just going to put everything in a try catch. Call it from server. So let's construct a socket and construct two arguments, host name and port number. So host name is Linux engrcs.com and port number is going to be 80. So that's the HTTP server, or the web server. And then let's construct a scanner from socket from server.get input stream. Let's make a print writer also. So print writer. Send to server. So we'll make a new print writer on socket from server.get output stream. So now we can send and we can receive. So let's send the page request. So send to server print line get tilde nic /shared /223 /lists /main.java. And then we'll go into our usual read loop. So while read from server has next line. And we'll call next line, we'll just print this out in a loop. And we'll close, and we'll close. And that's all a try catch block. Alright, it's the same stuff we've been doing for a week or so. But we're inside a loop here. So we're a little low on time, so I'll go ahead and put my flush in here after I do the print. Because if you don't flush, nothing's going to appear to happen, because you got to actually force the bytes out. All right, so what are we doing? We're opening a connection to port 80 on the Linux server. We send out a GET request, which will ask for that particular file from my directory, and then we'll just read from the socket as long as there's stuff, and we'll print it out, standard out, and see what it gives us. And when I run this, I get our bad request again. And it's not a typo in this case, it's a quirk. When you talk to port 80, it expects to see a carriage return before the new line. And if it sees all of this followed by a new line, but it doesn't see that character 13, it's going to say bad request. So I put a /R in there. And I run it, and there's my file. So I haven't tried this, but let's try this. Let's see what Clark EDU has on page 80. I don't think this will work. Yeah, so it doesn't like that. Because most people don't use port 80 anymore, because it's considered insecure. So most web servers use port 8080 or something else. So that's basically the mechanics of how some of this client server stuff works. Now we're going to find better ways to deal with web pages. There's a class called URL that does a lot of this work for us, right? But we could do it just by creating sockets and sending out gets and coming back, reading back whatever gets sent to us and so on. And there's a whole protocol for interacting with web servers, right? If your get string includes things like question marks, you can actually specify variable values, so you can pass basically inputs to commands on web pages, so you can fill out forms or ask for things to happen. And then, you know, of course, there's all kinds of layers on top of this. There's PHP and other, you know, languages sitting on the back end of these things. But basic mechanism of fetching pages from a web server, right, is really just a very simple handshake. And you can do it with just plain old sockets. You can do it from Java, you can do it from C, Python, you can do it from assembly language if you want. You can do it on a PIC processor. Right, so we're many layers above the hardware at this point, right? If we're doing Java, we're running inside a JVM, which is running, you know, is written in C, and it's using a TCP/IP stack, right, with TCP and IP all the way down to a physical layer and so on. And, you know, ultimately it's running on flip-flops in a state machine down at the hardware level. But we've touched on all of those levels, right, over the past couple of years. So so you should be getting, like, you know, most of a complete picture. All right, so tomorrow I want to talk about a little bit more about thread management for PA5, because there's one trick. It's kind of an end game kind of thing, but when you shut down a connection, there's a bit of a trick to how you get the server to respond to that gracefully. And it has to do with something we've touched on before, which is blocking versus non-blocking I/O operations. So we'll play with that a little bit tomorrow. If you did not turn in your SLP proposal, which was due this morning, turn it in like right now, or like right after class, okay? It's still open, and I'll take off some points for being late, but please turn that in, because it's like 35 points, I think, out of 100, I believe. All right, so I will see you tomorrow.